My name is Tetiana Dushenkivska, and this is a picture of me in Ukraine before the war, in the city called Kharkiv, where I grew up. The main square in this city used to look like this, and now it looks like this. War brings destruction and anger. War doesn't have winners. War does not determine who's right, only who's left. That's why every day I wish for peace. I wish for peace worldwide. In my heart, I believe that concentrating on creation, improvement, and restoration would make the world a better place. So today, I would like to talk about becoming a more confident programmer, a better self. Before improving myself, it helps to understand where I am on the learning curve. How good am I with Elixir? And how about you? Where do you think you are on the learning curve? You a beginner? Maybe you're somewhere here? Maybe you are an expert? What if I tell you that the learning curve actually looks more like this? This curve called Dunning-Kruger effect, and it was inspired by a crime. In 1995, MacArthur Wheeler robbed 2 banks in America in broad daylight. He was surprised later when he was arrested, as he believed that covering his face in lemon juice would make him invisible to the CCTV cameras. Inspired by not only his incompetence but also his lack of awareness, researchers Dunning and Kruger ran a series of studies to see if lack of ability is linked to low levels of self-awareness. What they found was interesting. The less a person knew about something, the more confident they were of their abilities. On the other hand, the most competent tend to underestimate their abilities, and this is often referred to as the burden of expertise. As in an article called Unskilled and Unaware of It, the Dunning-Kruger effect was born. Today, I would like to share with you a challenge I was faced some time ago. I was asked to help a team of developers to navigate across the valley of despair to the slope of enlightenment. The challenge was to help the team of 5 to become confident with Elixir in 3 weeks. The team already had experience with Python and Go and had begun their journey with Elixir. They were remote, and extra challenge was that the team needed to keep delivering at work. I had doubts about saying yes to that challenge, as I had doubts whether I would be able to help. What if I just waste their time? What if I don't easily understand their business needs? What if this or that? But I knew that I'm a little bit further along the curve, so I should be able to help. So, doubts aside, challenge accepted. Now, if you were faced with a challenge like that, where would you start? How would you help a team of 5 to become confident elixirists? This is what I did. 3 steps to achieve the goal. Step number 1. Understand what gives me confidence with Elixir. 2. Identify the team's overall knowledge and understanding with Elixir. 3. Build team confidence. So, what gives me confidence? Confident design and confident code. What do I mean by confident design? There are a few things I include in design. One of them is purity. Purity is understanding of concept of pure functions and striving to separate pure code from impure. It's one of the first concepts you come across when you start learning about functional programming, and it's the one which can easily slip away from you when you work on real-world projects. So, why should you care about writing pure functions? With pure functions, dependencies are explicit. Pure functions are portable because you can easily copy a function from one module to another. Pure functions are testable, and it's easy to pass in an input and evaluate on output. Pure functions are memorizable because the answer of the first invocation can be remembered, so function only needs to be called once, which makes them fast. Given the same input, you always get the same output, and thus referential transparency is preserved. This makes pure functions easier to write and reason about. This contributes to a code base that is more maintainable. They help writing parallel code. We can run any pure function in parallel since it does not need access to shared memory, and it cannot have a race condition due to some side effect. And what else gives me confidence? Understanding what data types are available to me and when to use them. I would like to share with you how I choose one data type over another. It's idiomatic Elixir to use map to pass parameters and to use keyword list to pass options. The question is, why would you use one associative data structure over the other? Associative data structures are the ones that can associate a certain value or multiple values to a key. So why would you use keyword list instead of a map? The answer lies in characteristics keyword lists hold. Can you name them from the top of your head? I've prepared a little game of discovering characteristics to test the knowledge. What would this return? Syntax error. In keyword list, keys must be atoms. And what would this return? One. It's because keys are ordered in keyword list. And what would this return? In keyword lists, you can have more than one key with the same name. These characteristics are what prompted keyword lists to be the default mechanism for passing options to functions in Elixir. Actor Library makes use of these characteristics to provide an elegant DSL for writing database queries. A good understanding of types helps me write idiomatic and performant Elixir. Code organization is important in giving me confidence too, because well-organized code is easy to understand and maintain. I like to organize the project using umbrella applications. Why organizing in umbrella applications? Well, I have 4 reasons to do that. Within an umbrella, the dependencies for each application are clearly defined in the mix file. Let's have a look at an example. Here we have 3 applications under the umbrella. Auth Web has the sole responsibility to handle web requests. Auth's sole responsibility is to handle authentication, which is done using Guardian at the moment. To store any data, Auth will talk to the store application, which has Actor as a dependency. Auth Web doesn't know anything about Guardian, Actor, or underlying Auth implementation. Auth doesn't know anything about Actor. If we were to replace Guardian and use something else for authentication, Auth Web wouldn't need to know about it. Another reason to use umbrella applications is that they allow you to design with deletability in mind. That's an idea borrowed from Greg Young. The idea is that you can delete or replace functionality quickly. Let's say we want to change our Auth app to use custom mechanism for authentication instead of Guardian. With current design, it's easy to do. We can write our new Auth2 app, which would use custom authentication. Then, when we don't need to use redundant auth with Guardian, we delete it. The beauty of this is that auth web or store wouldn't need to know about this change. This is how I see it. Imagine that you need to unplug something in this system. Would you prefer to remove cable from the left or the right? Another reason to go with Umbrella apps is the ability to have an application per DDD context, DDD being domain-driven design. Using the same terminology in code base as in business makes it easier to communicate between developers and business people. Here is an example of using ubiquitous language within the umbrella. In Auth application, our user called user, but in the games department, they don't refer to them as users, they call them players. Similarly, in the shop, we have customers. In editing department, we have authors, but all data is stored in the same users table. Last reason for using umbrella apps is not applicable to everyone, only for those who are deploying using releases. You can have lots of application under umbrella, but in release only include what you need for particular functionality. For example, in Elixir flashcards project, we have many applications, as you can see here. If you want to deploy a new version of our editor server, we will only include a subset of the applications in the umbrella. It will be a different subset for a game server and different for a shop server. However, we get to keep the whole project inside one GitHub repository, which works well for us. So, clear dependencies, deletability, separation into contexts with ubiquitous language, and deploying with releases are the reasons why I would go with umbrella applications. However, there are times when I wouldn't go with umbrella applications. If it's a simple project, umbrella applications may be an overkill. Also, if I don't know how to break my project into umbrella applications, I would start with monolith and refactor when I have a better idea of what is a good abstraction. The last thing you want is to end up with circular dependencies. Bad abstraction is worse than no abstraction. I like the applications within the umbrella to have a good README and clear, well-defined interface or public API. There are a few pros of using interfaces. You can define clear public API, taking advantage of Elixir's ability to add nice documentation and specification to functions. Here is an example of the public API for auth application. With module doc, we can describe the kind of functionality available in this context. Then list all the publicly available functions with their docs and specs. In this module, we use delegate to delegate functionality to subcontexts. Another reason of using interfacing is that they allow two teams to work simultaneously as far as they define a contract upfront and keep it. Another advantage is that keeping the same contract allows replacing underlying implementation and things will still work. However, some of you may think that organizing projects in umbrella applications is useless, as there is no really a way to enforce all calls to the apps to go via that interface. Umbrella applications with clear interface. And inside context, I strive to write as many pure functions as possible and push impure stuff closer to the boundary. Another thing I strive for is to create a struct when boundary is crossed and pass that structured data around within the application. That saves me from passing some invalid data down the stack to see it breaking things. I find that validating data and creating a valid struct can save me from a few errors. Also, if data is invalid, I can return nice message to the user straight away and keep business logic clear from formatting error messages. Here is an example coming from job application, where we create a new order struct and then passing it around the context. I love using structs and I have a few good reasons to use them. Struct provides a compile time guarantee, as shown here. For example, what would this return? A key error. And do you know what would this return? Here we use module attribute enforce keys. Argument error. Also, structs provide tighter type check, as they can pattern match on type of struct and function head. I know that not everyone in favor of this approach, which is fair enough. It's something I like doing when it fits, like in this example. Here we create an adult module where the age must be more than 18. And then drink module, we can pattern match on the struct to determine whether person is allowed beer or not. However, there is a potential danger with this approach. It lies in how struct is defined. Let's have a look. Do you know what this would return? A function closer. And this one? An adult struct. Which then results in a problem where teenagers and children are drinking alcohol. It's the same kind of problem as with interfaces. We can bypass going through interface and decide to call any public function we want in the application. With structs, we can bypass going through constructor function. You can add a guard clause here to check the age or agree with the team to comply standards of going through interface and new functions. There is no guarantee that this would happen. And another reason to use structs is it allows for composable and extensible pipelines. Actor does it really well. So in summary, this is how I like to organize complex projects. Separate pure from impure, push impure to the boundary, convert data to structs as early as possible, use structs inside the context. This is all good, but how about processes? I like them too. I tend to settle for a simple workflow, TTD implementation of the logic, then add state or concurrency by wrapping it into a process, then make it fault-tolerant by adding supervision tree. When working with processes, there are a few things I've learned over the years. One of them is that you got to restart Gen server with a new state, because corrupt state is likely to be a reason for failure. That's why restarting with a corrupt state would fail again. Once we exceed number of allowed restarts within given time, we could take our parent down, and as a result, the rest of the tree as well. Also, I like to extract functionality out of the process in most cases. It makes it easier to maintain, as extracting functionality into a module allows you to use an intention revealing names and ability write docs and specs to functions, which take care of accepting state and returning a new state. And it's easier to test, as your tests can now use ubiquitous language. Here is an example of the worker which takes care of implementing a game. You can't see it very well, but what's happening here is worker implementing a handle call to display next card in the game. Now compare this code to the version where state update functionality is out of the process. Here it is. It's easier to see the life cycle of the process. Purity, types, organization, and architecture gives me confidence in my project. Writing applications on the beam involves message passing between processes. In order to ensure applications remain decoupled, I find that event-based architecture is a good fit, not to be confused with event sourcing. What I'm talking about is event-based architecture, where you send events to a central broker and all subscribers of this broker receive and process events asynchronously. This architecture is called a broker topology. With this architecture, you can decouple your applications. Being confident in the way you design your project is great, but it's also good to know that your software works now and will be working tomorrow. That's what confident code is about. We have our beautiful project in Elixir. Where would I start to make sure it works? Unit tests. I would have them in place by the time I finish my implementation, because I usually TDD my implementations. Next up, integration tests ensure the applications work together. For example, integration test would be test going from auth web into auth. To make sure auth web tests are fast, I would mock external dependencies from auth application using mocks library, for example. However, I don't recommend mocking the database. And with those, this is our foundation to protecting our Elixir code. And next up, I like style to be consistent with the rest of the Elixir community. And this is where format is great. Reader will give me confidence that things are consistent within my project. With test coverage, I'll have an idea if I'm missing some tests. Next up are the serious guys. Dialyzer helps me ensuring that specs are aligned and help me find some bugs I wouldn't even think possible. Smoke tests are the tests which go through the stack, starting from browser making a request and returning a response. And to be super confident and help identify some edge cases, I would use property tests where it makes sense to use them. And when things go bad, debugging and tracing to the rescue. And with all of those tools, I have the tower protecting my beautiful Elixir code, and I have a confidence that things do work. And that's what gives me confidence. After understanding what gives me confidence, I had to remind myself why I did it. So I can help a team of 5 to become more confident with Elixir. So step number 2 in my challenge is to identify team knowledge. It's hard to help someone if you don't know what they know. To identify where team is on the learning curve, I've used a few techniques. By reviewing the project, I get an idea how Elixir is used, what practices and concepts are followed. The things I looked at during review are code organization, design patterns, consistency. What would I look for when it comes to organizing code? Things which make me confident with Elixir. Here is an example of my findings. It was important to mention that what team already is doing well, not only things which can be improved. And once I've identified what is good and what can be improved, I had to share feedback with the team. One of the things I've picked up on was using nested cases and if else's. So here is an example of giving a feedback around nested cases. I would pick up a code example from the project where improvements could be done and show it to the team. After looking at the example and understanding what code is doing, I would suggest an improvement. There is a simple way to determine if you need to refactor. You stand back and you squint. If it goes to the right a lot, it's time to refactor. Then I will leave to the team to decide whether they are happy to adopt my suggestion or ditch it. By reviewing the project, I get to understand where the team is on the learning curve. Once I reviewed the project, I've used another tool from my toolbox, the flashcards. Flashcards contain a question on one side and answer on the other side. They're great at identifying knowledge gaps around terminology and Elixir API. Well, let's see if you have any gaps in your knowledge. What would this return? Okay. What do you think this would return? Undefined function error. I sometimes forget this. That's the real function. Let's return a string. By using flashcards, I get to understand where each individual is on the curve. Also, I was pair programming with one of the developers from the team at a time on a piece of work they were doing at the moment. It was a remote pair programming using Zoom. We left the meeting open to anyone to join, so anyone can see what we're up to. The agreement was not to interrupt the flow of the pair. After pair programming for 3 hours with each developer, I get a better idea what each individual person areas of work to look at and what their personal goals are. Pair programming helped me understand how each team member is thinking when coding. After pair programming, I realized that my initial plan of covering some topics had to change, and I had to make sure the fundamental functional concepts such as purity is well used within the project. So initially I thought this is where the team was on the learning curve. Actually, it was more a bit like that. After identifying team knowledge, the time has to come to fill in knowledge gaps and build team's confidence about using Elixir. And how to build team confidence? Via mentoring. Mentoring is not teaching or lecturing. It's about helping individuals to define a goal, come up with a plan, and provide support and motivation on the road to succeeding with achieving the goal. There are 3 techniques I've used while mentoring. What is the first one? Flashcards again, this time as a revision tool. When you look at the front side of a flashcard and think of the answer, you are engaging a mental faculty known as active recall. Active recall has been proven to create stronger neuron connections for that memory trace. Also, they can be used with confidence-based repetition. Looking at the curve of forgetting, you can see that the more you recall something from the memory, the better it will stay in the memory. Confidence-based repetition is a technique of remembering an information by separating practice sessions in time. Also, I used presentations. Presentations help to share the knowledge with all team and to have something left for reference. Here is an example of the presentation structure which seems to be working well. This example comes from presentation about purity. Identify knowledge gaps with flashcards. It's important to only focus on things the team don't know. So what is the answer to this question? The team gives an answer. If everyone got it right, then skip the explanation. If at least one member of the team got it wrong, move to explanation. The important thing during mentoring is also record which cards has been answered correctly, so in the future you can come back to the wrong ones. For me, it was important to track progress and at the same time keep each person on the team happy, so I was recording the progress for the team, such as 4 out of 5 answered correctly, rather than pick up on a particular individual. Let's say 4 out of 5 answered correctly this one. In this case, I would go through explanation. Here we go. For example, current function is pure. Given the same input, it will always return the same output. Given 1, it will always return 2. On the other hand, this function isn't pure. Given input 1, it can result in 2, 3, or 4. After explanation, little test around purity in Elixir. Start simple. What is the answer here? Is this function pure or impure? This one? That one? This one? Cool. After answer what, it's quite important to discuss why. Can you think of benefits of using pure functions? And after answering why, it's time to move to how. How would you benefit from purity in real-world projects? We all know that most projects would need to contain pure functions to maintain state, talk to database, print to console, make HTTP requests. The key thing is to make as many functions pure and push impure stuff closer to the boundary. It can be done in 2 simple steps. First, identify pure and impure functions. Second, make as many functions pure by passing in required data. And then I would pick up an example from the project and walk through separating pure from impure. So in this example, we find the pure stuff and impure stuff. Then we pick up the impure stuff, move it closer to the boundary, pass down the ink by value, and then we do the same again. We find the impure stuff and pass it and move it closer to the boundary. And then our ink function is pure and easy to test. One step is to provide links to relevant reads, presentations, and so on. And once knowledge has been shared, we've used pair programming to solidify that knowledge in practice, identify new gaps to become confident with implementing theory in practice. While pair programming, I had to remember to provide guidance, not lead, but to concentrate on discussing various approaches to a problem, paying close attention to pros and cons of each. The key was to let the team make an informed decision about the approach they want to adopt for their project. Pair programming was a great place to share the way I think about the problem, some tips and traps I've experienced from working for numerous years with Elixir. And after pair programming with each member on the team on a particular task that person was working on, they all got different knowledge. So in a way, they were mentors to the rest of the team on that topic. And I, with help of flashcards, presentations, and pair programming, had a lovely time mentoring. I found out that there are a few tips for a successful mentoring. Ask questions correctly. I often would explain the subject and then ask, "Did you understand?" Often the answer was, "Yeah," and I just moved on. However, asking questions before explanation is more beneficial. Also, asking "Why is this like that?" "What did you understand?" instead of "Did you understand?" worked like a charm. And flashcards can help memorize things. As mentoring, not lecturing, it's important to remember to explain how and why something works and give options to the team to choose the best approach for them. Concentrate on good things and achievements as it's motivating. And one of the things which didn't work was not having a challenge for pair programming. It worked when the guy had something to pay on, some feature, bug fix, some other piece of work. And with those three steps, first, understand what gives me confidence. Second, identify team knowledge. And third, build team confidence. We were able to achieve the challenge and help the team cross the valley of despair and climb the slope of enlightenment to become confident with Elixir. And as a bonus, I got a really good feedback. Today, we have talked only about one curve, the big learning curve to become confident with Elixir. However, when you think about it, there are many small learning curves which you are in different positions on the curve. Maybe on some you're already a master, maybe others you have yet to cross the valley. If you haven't tried mentoring, I encourage you to become a mentor on a subject you know well and seek for a mentor on things you're yet to master. Why would you want to be a mentor? Well, it feels good to share experience, develops better understanding of subject, and as a bonus, as a mentor, you get to develop communication and leadership skills. Being mentee is also good, as your time spent effectively with the help of mentor, your learning is tailored to your personal needs, which results in you progressing faster and transition fast through the valley of despair. It looks like successful people can see value in mentoring and often thank their mentors in their success. Steve Jobs had Mike McCullough as his mentor. Let's help each other to become successful. Thank you for your attention and thank you for supporting Crave. And as a bonus, I would like to share with you something all Ukrainians learn at school. The blue on Ukrainian flag represents the peaceful blue sky. The yellow is for fields of wheat. Thank you for your time.